extra example number 3 from section 7.2, adult internet users. So about 75%, you already know this about the population of all young adult internet users watch online video. So we already know that the parameter, P, the proportion is 75%. Suppose that a sample survey contacts a simple random sample of 1,000 young adult internet users, so sample size N is 1,000, and calculate the proportion P hat in that sample who watched Game of Thrones. Okay, so the first question is, what is the mean of the sampling distribution of P hat? So if we kept taking a bunch of samples and plotted them, a bunch of P hats, what would the mean be? Well, and we'll use notation for that. The mean of P hat, if we kept doing that, would be the same as the population proportion, so it would be 75% or 0.75. And I'll use notation, and the reason is because you could practically use your notes exactly, because the mean of the sampling distribution of P hat is the same as the population proportion. That's why. Because the mean of the sampling distribution of P hat is the same as the population proportion. And we were given the population proportion of 75%. Okay, B is find the standard deviation of the sampling distribution of P hat. Well, that would be, we'll use the right notation, standard deviation of P hat equals, the formula says the square root of P times 1 minus P over N. P is the population proportion, which is, 0.75 times, what's P naught, or 1 minus P? 0.25, and the sample size is 1,000, great. So you do that on your calculator, and you should get about 1%, 1.3%, or 0.0137. And then after the fact, we're checking a 10% condition. Usually we check before, but certainly the way you would write it is certainly there are greater than 10 times 1,000 or 10,000 adult internet users in our population. We can just assume that. So our 10% condition's okay. And then we're going to check the normal condition. Is to see if it's normal. So we'll check. We'll say is NP. So NP would be, what's N? And what's P? 0.75. So what do we get? Move the decimal over 3 places. We get 750. That's greater than 10. Good. And then we check N1 minus P. This is exactly how you'd show it on the AP test. On your problems is 250. So both are greater than 10. Both greater than equal to 10. So that's good. The normal condition is met. So yes. Yes, we should say that somewhere. And finally, okay, so if we increase the sample size to 9,000, how would that change the sampling distribution? So when you're asked to describe a distribution, we're talking about shape, center, spread. So would the shape still be normal if you increase the sample size, if it was before? Yeah, so it would still be normal. So still, the shape is still normal. Let's talk about the center. The mean of P hat, would that change? It's still going to be 0.75. But the standard deviation is going to change. But by how much? What do you think? Standard deviation, we know it's smaller, but by how much? How much bigger is the sample? How many times bigger? 9 times bigger, right? So let's look at the formula for standard deviation. Is square root p1 minus p. That's not going to change. But instead of n, we now have 9n. So it's the square root of 9, which is, if we take it out of the radical, it would be 1/3, right? So it's a third of the size. It's smaller by a factor of 3. So the p1 minus p doesn't change, but now we have a third of the size. So the standard deviation is smaller by a third, or by a, yeah. If the sample size is 9 times as big, because we're taking the square root.